Hi, my name is Owen Felty. I'm the 3D printer manager here at the College of Architecture and the Built Environment. And today I'm going to walk you through how to 3D print here at the college. We're going to go through what is 3D printing, how to design for 3D printing, and how to print at our print farm over in Seed. So first we'll start off with what is 3D printing. 3D printing is the process of taking a digital model from either SketchUp, from Revit, from Rhino, any sort of digital modeling program, and bringing it to real life via layer by layer plastic fuse deposition modeling system known as a 3D printer. A 3D printer works basically by taking a plastic filament and superheating it through a nozzle so it's liquid and depositing it onto a build plate. And doing this layer by layer by layer. You can see here on the screen. On the left here, you can see this is exactly what the printer is doing. A 3D printer usually works in three axes: an x-axis, which is left to right, a y-axis, which is front to back, and a z-axis, which is up and down. Utilizing all these three axes, we can create models we can create basically any sort of digital model that you would like with the use of supports and some other things we'll talk about later. You can see on the right here is an actual 3D printer, 3D printing something. These are the models of 3D printers we have in our print farm and Seed. You can also see here another sort of time lapse on how 3D printing works. It's just layer by layer by layer. 3D printing, unlike laser cutting, takes quite a while. 3D printing, I'd say the average sort of file we get in the laser lab is about 8 to 10 hours. What you use 3D printing for is kind of for fast iterative models, also for very detailed small models as well. You can make some very nice sort of screens on an architectural model with that, right? We tend not to make huge, large kind of volumes with them. Those would be better made and faster made at the wood shop. Something like that would take a ridiculous amount of time to make, so we sort of um, kind of shy away from that. Any sort of print that is over 24 hours we do not allow in the print lab here. So that is sort of what is 3D printing. Now we're going to move into Rhino. This tutorial is a very basic tutorial showing you how to model in Rhino. We will not be going over any other 3D modeling programs. So we'll switch over to Rhino here and we'll get started with design for 3D printing. Okay, so here we are in Rhino. You can see I have a basic file set up, and before we get into anything, right off the bat, the most important thing you have to know before you start modeling anything for 3D printing is first of all file setup. Now when you want to 3D print something, I highly suggest making a completely separate file than your digital model is in, and then converting everything over to that, and make sure you scale it correctly, make sure the units are right. Okay, so you want to make a completely new file, right? And we want to make sure when we set up the file that we go here to File Properties. We want to make sure our units are in inches because the program that we're going to eventually bring it into reads things in inches. Okay, with that done, the first thing we should kind of design for is the build plate area. The build plate area of our printers in the print lab are 8 inches by 8 inches by 8 inches. So I have it right here. We have 8 inches. We have sort of an 8 by 8 square here on our x-axis, left to right, our y-axis, front to back, and our z-axis up and down here. You cannot print anything larger than 8 by 8 by 8. The printer will not function. It will not work. Okay? And I highly suggest as well making a little sort of border here on the inside. So what we can do is we could just do a simple offset. And then we can offset, I'd say, probably about 1/4 of an inch from the actual edge. So really the maximum you should go is 7 3/4 inches. And that goes for the z-axis as well. Okay, just so we have enough room so it's not completely right on the edge, because then we run into some build plate adhesion issues. So we can model within this 7 1/4 by 7 1/4 by 7 1/4 cube. And make sure when you're modeling, everything is to scale, right? We don't want to, bring something in from your digital model and have it be absolutely enormous. You want to scale it beforehand, then bring it into this file, then put it on the build plate, right? And when you're modeling things for 3D printing, when you're designing things for 3D printing, we have to keep a few things in mind. First of all, is whether your object that you're making is a closed or open poly surface. This is absolutely essential when 3D printing. right? We call this whether your model is watertight or not. What is a watertight model? So we click on this sort of cube here, this very simple geometry, um, and you could see up at the top left here, it says one closed poly surface. That is good. That is what we want when we model something. We want it to say closed poly surface. What we don't want is if we click on this cube over here, it says one open poly surface. An open poly surface is something that has multiple faces and edges that have been joined together, but is not a solid. It is not closed. How do I tell that this isn't closed? Well, if we simply rotate around it, we can see that this side is completely open, right? Very easy fix to make. You just put a surface on that, and then boom, it's a closed poly surface, just like this one, right? You can make a closed poly surface via this sort of solid tool over here. You could do all of your solids. All of these will be closed poly surfaces. You could make a bunch of regular planes and orient them so they make a closed solid, right? Kind of like this one right here. This is just a bunch of surfaces that I put together, but you could see up at this top left corner, it still says one open poly surface. If you're not very precise with the way you make surfaces, and again, these cubes are sort of the very basic modeling unit you have, your models are very likely going to be much more complicated than this. So it might be a little difficult to find these seams. You can see these seams on this one are fairly obvious, right? The seams you have on yours could be microscopic, and you'll have to zoom in forever to see them. I'll show you a fancy tool that I usually use that helps me see open edges like this, right? The reason this is an open poly surface is because there's open edges, right? So if we do a command called show edges, you can see up here in the top left, and click enter, and then we select all naked edges there. And naked edges is an edge that's not closed. So you can see here, they all highlight in pink. So we can see exactly which edges are open. You can see we have some little overhanging edges here as well. Those don't matter too much. It's just the ones that make the poly surface open, right? So how do we fix this? Well, the naked edges, or sorry, the show edges command works great with the connect surface command. So we click that, and then we click on the two surfaces that we want to connect. So we click on this surface here and this surface here, and it closes them. And you see they're no longer outlined in pink. This is exactly what we want. And we do this with the other one over here as well. We go like that. Oh, sorry, I need to redo the command. So I right click to redo the command. First surface near the edge, so we do this one, and there you go. It is if we click on it now, it says up here, one closed poly surface. Now you may have to do this a bunch of times for your model wherever it shows those naked edges. You can see here, if I click on this model, no more naked edges, right? They're all gone. You have to do this on your model for every single naked edge there is, or else it will not 3D print. When we bring it into our other program, the program will not compute open things, right? If we have open objects like this, made out of planes, planes do not have any sort of thickness, right? It is just like a piece of paper. You can't print a piece of paper. There is no thickness, right? This is a physical model we're making. Physical things exist in 3 dimensions. Planes only exist in 2 dimensions. So the printing program cannot process that, right? You need to make sure this is the case. And it doesn't have to be with just poly surfaces either. You can export meshes, you can export things, other solids of that nature, right? They just have to be closed, right? Another big issue I see in the print lab is people bringing in things that aren't flat on the build plate. If things aren't flat on the build plate, then they won't stick to the build plate. Build plate adhesion is absolutely essential when we're 3D printing. Okay, we want things to be flat. We want them to be stuck right to that build plate so they don't warp off, especially when it's cold outside. So we want things as flat as possible. Now, it's very difficult to tell sometimes that things are flat, but you have to do some thorough inspections here. But you can just see, as we go down to the surface, this cube is ever so slightly angling back like that. And that's all it takes to mess everything up in your 3D print, right? So how do we fix this? We can fix this by using the orient 3-point command, right? Simply like that. And what we do, we take the edges that are skewed. So it's this edge back here that is mostly skewed, but this edge here is fine. So we take the orient 3-point command, we click on one point, we drag along our skewed edge to another point, and then we drag along another edge to another point. Now we have all 3 points of this cube. So whatever we orient it to, it will be flat. As long as the object we're orienting it to is flat. So everything else in this file we know is flat. Okay? So if we go to this guy, and then we go here, and then we go here, our cube has just become flat now. Right? If we look at it again, we ZS onto it, and we go down, we can see it's completely flat. That's because the Orient tool mimics all of the points of our flat cube here. It just takes it, so all the points we selected on our skewed cube oriented to the flat points here. Very simple. All right, so that is absolutely essential. You have to remember that. Okay, and now when we go to something that is overhanging, this is a very interesting condition because it requires a little bit more tweaking. It requires just being smart with 3D printing, right? So if you have something that is overhanging like this and you're using a 3D printer that builds up things layer by layer by layer by layer, what happens when there's nothing else to build on, right? When it's building this rectangle here, it's building it up and building it up and building it up, and when it has to do this layer, there's nothing there. How does that work? Well, in the slicing program, in the program that we're going to bring this into, it will generate something called support material. Support material goes underneath any overhang over 45 degrees, right? Typically, a 3D printer can print anything up to a 45-degree angle perfectly. Anything over that, it needs something underneath it, right? There's just too much of a percentage that's overhanging at that point that it can't do it stably. It needs some sort of material. So the support material is basically just thin, sort of gridded plastic underneath these overhangs that is very easily removed once your print is done. Now, support material takes a while to print as well because it's also doing that layer by layer. Granted, it's not as thick and it's not as complicated. But if we design smartly for 3D printing, we can minimize and reduce and eliminate support material sometimes entirely, right? Just by flipping this print upside down here, you can see no support material. It's going to take probably a third of the time to print now. Very simple. So things like that, right? So if you have an overhang and you can minimize it by flipping something on its side or turning it around, do that. It's going to save you a lot of time in the future. You have to remember 3D printing takes a while, right? 8 to 10 hours, sort of average 3D print for what we do here at the college, right? You got to keep that in mind. So over here, we have another example. Just some sort of simple stairs, the 3D print. I see stairs printed all the time, especially for first years. And a lot of them I see don't do it correctly because they don't really know how to 3D print. So I'll show you here how to do some stairs. You can see these stairs are only joined right here at one single edge, right? But again, we're making a physical model. That is just one dimension that this exists in. It's just one singular edge. It doesn't exist in 3 dimensions. So when this prints out, it will print this stair and this stair and this stair and this stair and this stair. It won't print them all as one solid staircase, right? To fix that, we could do something really simple. We could just take one of these little cubes, these basic cubes that I just made all of these stairs out of, and just put it here at this edge, and suddenly that edge has dimension, right? So now, it's all one continuous sort of solid as it goes up here. So it will print this whole thing as one solid poly surface now. And typically with things like this that are a bunch of different pieces, I would Boolean union them before bringing them into our 3D printing program, just so you're making absolutely sure that it's not making any mistakes bringing it in and over there. Okay, so the next kind of condition we're going to look at is the building condition. We print these kind of volumes a lot at the college, obviously, with sort of walls, a floor, and a ceiling, right? The problem with printing buildings as is, just like this, is they tend to overhang, right? Roofs overhang to create an interior space. It's architecture, right? But when we're 3D printing something like this, and we have an overhang, that means that overhang needs support material, right? So if we were to print this as is, this entire interior space would be filled with support material, right? And if we were to print it like that, it would, one, take quite a long time to print all of that support material on the inside, and two, be very difficult to take out. Even with a pair of pliers or tweezers, it would still be very difficult. So what can we do to address this? Well, I'm going to teach you how to break apart a model. This is essential in designing for 3D printing, is breaking things apart to strategically 3D print them efficiently, sort of saving you as much time as possible. So what I suggest for printing sort of building volumes is taking the roof off. It's completely splitting it from the rest of the model and printing it separately. So we can do that pretty easily just by making a surface. We can click on the surface tool here. We can go to our top view and we can create a surface that completely encloses the model here. So there we go. It doesn't have to be perfect. It just needs to split the model. So here we have our surface, and now we're going to move it up, 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 up until we can see that it's clear of all our windows here and that it's solely cutting through our roof here. Okay, and then it's as simple as just typing in a Boolean split. We select our building, press enter, and then we select our cutting object and press enter. Okay, and now our roof and our building are two separate objects. So if we go ahead and hide our surface here, and we take our roof off, we can see that it's split like this. Now, we wouldn't print it as this and this, right? As is, right? We would take this, first of all, and flip it upside down, right? Because if we had it in the other position, it would still need to be filled with support material, right? And we could see our roof here is just slightly sort of sloped, right? It's a sloped roof condition, so it collects water, right? But that means when we're 3D printing it, it's not flat, and flat things aren't good for build plate adhesion, as I told you earlier. So we can use sort of the other thing that we learned, our orient 3-point command. We can take our reference point of here. This is the edge that is skewed to here, and we could put it against something that we know is flat, like these cubes over here. Right? So we go here, here, and here. And now we know our object is flat. So if we move it, we go take it over here and bring it over here. We can move it this way, and now these objects are flat on the build plate. Well, this one is turned over again. You have to look out for that when you're using the orient tool. Sometimes it flips over your object. But there, this is how you would print a volume, an enclosed volume. And then after you're done 3D printing this, you would just take this volume, put a bit of super glue on it, and then attach it to the top. Right? That saves you hours of 3D printing because you don't have to put in that support material. Okay, so I'm going to go on this build plate here, and I'm going to model something very quickly. Right? I will be right back. Okay, so here I've modeled something very simple, but it's going to teach us a lot when we go into the slicing program. So here, it's just a simple overhang with something cut out of it, sort of this bulky volume. I don't suggest you ever print something like this. This something is much better made at the wood shop, right? But it'll show you kind of the basics of 3D printing here. So how do we actually export this from Rhino and bring it into our 3D printing program? So what you're going to do is you're going to take your volume, you're just going to click on it, you're going to make sure it says one closed poly surface, and then we're going to type in export. All right? And this is going to bring you to some random folder. Make sure you know what folder you're bringing it into. I think this one's fine. And then we're going to hit this little drop-down menu here that says Rhino7.3dm models. We're going to change our file format to .3dm, and we're going to scroll all the way down to the bottom where it says .stl right here, stereolithography. This is the file format that every single 3D print should be exported as. So we're going to click that, and we're going to name it whatever we want. I'm going to name it 3D Print 1. Right? And then there we go. Now, this is our other menu that pops up. These are our options for our STL. So this is basically detailing the tolerance of the mesh that your file will be converted into. It's a lot of technical jargon, basically, but what really you should be looking for is this number is never 1. It should always be 0 point something. It should never be 1. If it's 1, you have an open poly surface, or if it's close to 1, you have an open poly surface, right? It should always be 0 point something. Okay? So we click OK again. Wait a minute for it to mesh. There we go. Sometimes it takes a while. I recommend, if you're doing curves and curvilinear surfaces, especially if you're working with sub-Ds in Rhino, to mesh it first. So turning it into from a poly surface to a mesh in Rhino simply by typing in the command prompt mesh and then pressing enter. Right? And then that just simplifies the geometry. If you're running into problems, your STL file is taking forever to mesh it first, then export it as an STL. Right? All right, so back to the STL export options. This should always be check marked as binary. If it's checked to ASCII, check mark it to binary. Okay? And then click OK again. I'll show you here what I mean by meshing something. You just click on your object, you type in mesh, you put in more polygons, and then instead of exporting this closed poly surface, you go here, it says one closed mesh, you export this instead, and it should export much quicker. Okay? But now, since we have our .stl file, I'm going to take us out of Rhino here, and I'm going to show you how to download our slicing software to convert our Rhino model into something that can be 3D printed. Okay, so now we're going to download our slicing program. Now, what is a slicing program? A slicing program takes our digital Rhino model, or digital whatever model, and converts it into individual layers of plastic. It's called a slicing program because it actually slices your model into 1,000 or something layers of plastic, and then generates a type of code that the robotic 3D printer can interpret and print, right? It's just taking your model and converting it into something else, basically. And it has a bunch of settings and parameters that you can adjust to make it go faster, make it print in a specific way, things like that, right? But the slicing software we're going to use is called Prusaslicer. So we're going to go in Google here. We're going to type in Prusaslicer and press enter. Now I'm using Chrome here, so it should be the first link here on Chrome. You'll be brought to this page upon clicking on it. And right here, you'll click download for Windows. Everyone should have a Windows laptop, so everyone should click download for Windows. All right? And you'll just wait 10 seconds. See down here, there's a countdown. Don't put your email in. They try to get your email. Don't let them. There we go, and the download started up here at the corner. And once it's done, you can click on it. Click OK. You hit next. You hit next, and then you hit install. Now I already have the program installed, so I don't need to hit install, but once you click that button, it will be installed, and then it will automatically open up the program. Also, it will create a shortcut on your desktop, and it looks like this right here. It will install two things: Prusaslicer, the actual app, and Prusaslicer G-code viewer. We don't worry about this for now. We'll just worry about this. So once you have it downloaded, it should open up automatically. I'm just going to open it up here for you. Alright, once you open up Prusaslicer, you should be prompted with this screen. This is a configuration wizard. This is going to install the presets for our specific printers that we have in the laser lab. So we're going to go down here and click next. What we should do, I think by default, Prusaslicer has one of these buttons here checked. I think you should uncheck mark one of these buttons that are up here. After you do that, we'll scroll down until we see Mark III family. You can see it's right here, Mark III family. The printer we have is this first one here, the Prusa i3 Mark IIIS. And we're going to check mark, I already have a check mark here, but you have to check mark 0.4 millimeter nozzle, never 0.25, never 0.6, never 0.8. All of the printers we have are 0.4 millimeter nozzles. So after you do that, you can click finish, since that's the only printers we'll be installing. And then you are prompted with our configuration view here. Now, this is kind of very similar to Rhino. What you can do is you can hold right click to pan around. It's actually the opposite of Rhino, sorry. You can hold right click to pan around, and you can hold left click to rotate around our build plate here. This is that 8-inch by 8-inch by 8-inch build plate here we have. This is what it'll look like when you go into the print lab. It'll have this little title here of what the printer is and this grid on it. You could tell you're on the right printer by it saying Mark III. We may be getting Mark IV printers in the future, and you'll be able to determine which printer you have because it will say a Mark IV here instead, and then we'll just install the preset for a Mark IV instead of a Mark III by going up here to configuration wizard, press don't install. And then running through the configuration wizard and check marking 0.4 or Mark IV printer right here at the 0.4 millimeter nozzle. Okay, so right click to pan, left click to rotate around the build plate here. And then we can bring in our model via this cube with the plus sign up here. So right now you need to go find where you saved your model. I believe mine is here. And it's in here, and then there it is. It'll look like this. This is a Prusaslicer file. It's your STL file, and all you have to do is press open. Might take a little bit to load in. Just be patient. Now, my model has come in very, very small, even though I correctly scaled it and put it on the build plate and everything in Rhino. That is perfectly fine, okay? Sometimes it does this. Most slicing programs work in a default millimeter units, right? I have you start in inches in Rhino because most of the time, it converts it over into millimeters just fine, brings it into scale. Sometimes, though, it brings it in very small. There's a very easy fix for this. You can see right here on the bottom, right here, you can see it says scale factors, and there's 3 100s. That means your scale is at 100% right now. So if we change this from 100% to 2,540 and press enter, it scales it uniformly, and that 2,540 is the scale factor from millimeters to inches. So this, right now, is at the correct size we scaled it in Rhino. Alternatively, when you bring in your model to Prusaslicer and it correctly interprets it from inches into millimeters, you should be prompted with this screen. It's very simple, this screen. All you have to do is click yes, and it brings it in inches just fine. Okay? And we can go around it. We can see what it looks like. Now, it's green right now. Green is good. That means it will fit in the build plate. If we have it just outside the build plate, it turns blue. Right? Same if you click off of it. If you click off of it, it turns orange. That just means you don't have it selected, right? Just like something in Rhino turns yellow when you select it, right? And if we put it outside the build plate and we deselect it, it'll be blue, okay? Now, to easily arrange something on the build plate in Rhino, you could click this little square within squares up here. It says Arrange. You just click on that, and it puts it right in the build plate here. Simple as that, okay? You could use your pan and rotate tools to look at your model every which way, make sure everything is fine. I'm not seeing any gaps or anything like that, so our model looks good. Okay, now we'll run through a few settings here on the right. This is what gives you most control over your 3D print. These are things that will affect time, quality, how it looks, everything. So the first setting we have here is our layer height. Now, what is layer height? You know how this slicing software is called a slicing software because it slices it into a bunch of individual layers of plastic. Well, those individual layers of plastic can be different heights. The lesser this number is, the more layers there'll be because each layer will be very thin, so it has to build more and more up to build your model. The greater this number is, the less layers you will have. So right now we're on 0.3 millimeter draft. So each layer is 0.3 millimeters, so that means there's less layers than 0.05 millimeters. Right now, the quickest one is 0.3 millimeter draft. So the less layers you have, the less time it needs to print, right? The more layers you have, the more time it's going to print. If you're running into time issues for your print, the easiest way to reduce time is to adjust layer height. So by default, I say 0.2 millimeter quality is fairly good. Either that or 0.2 millimeter speed, it doesn't really matter. If you're trying to get something done really quickly, kind of an iterative massing model, you can do 0.3 millimeter draft. If you kind of want something that has a bunch of kind of very small intricacies, I'd say the lowest you should go is 0.15 quality. There's really no reason to do 0.1 millimeter or 0.05 millimeter. That is incredibly long. That will take days to print, and again, that's not allowed in the print lab, stuff over 24 hours. So if you're going to print something very detailed, I'd say the lowest you need to go is 0.15. There's very rare cases where 0.07 and 0.05 millimeter are needed. Below that is the filament type. There's different types of plastic filament that you can load into each 3D printer. The only filament that we have in the Laser Lab stocked is PLA. All sort of filament is already there for you to use. You do not need to pay for 3D printing. There's no money involved in it at all. We stock different colors of filament in there, and they're all PLA, so you don't need to worry about sort of funds for anything like this, right? And they all should be to this default sort of PLA setting. It shouldn't be ABS, it shouldn't be PETG, it should be PLA. All right. And below that we have our printer. That was our preset we installed when we opened up Prusaslicer for the first time. So it should be on this sort of Mark 3S and Mark 3S Plus, right? It should be on that. That is the printer we are using. Okay? And you can see right below that where it says supports. These are the support material I was talking about in Rhino. So we can choose to generate. There's a few different options here. We won't go into this right now. It's default, just go everywhere. And that'll generate our supports. We don't see it now. We'll see it in a little bit. The next thing is infill. So when we make a 3D print, we don't want it to be completely solid, right? That takes up a ton of filament. That takes up a ton of time as well. So what infill does is everywhere that's an interior on your model, everywhere that's completely enclosed on all four sides, it creates a pattern, a sort of gridded pattern on the inside, or a gyroid pattern. There's a few different patterns, I won't get into that, but regardless, infill sort of dictates how the interior of your model will be, how dense it will be. So right now we can do 0% all the way to 90 or 100% even. There is no need to ever go above 100% unless you're purposefully trying to make a stone or something. There's no reason to ever go over 10%, especially for what we do here at the college. Right? Sort of, I think a good sweet spot is around 5%. 10% on the high end, 2% is on the low end. I think a good basis is 5%. And right next to infill, you could see a little check mark button that says brim. Now, what a brim is sort of the first countermeasure to warping. You know how I said earlier to use the Orient 3-point tool to counteract build plate adhesion? You want something as flat on the build plate as possible so it sticks there. A brim assists with that. Essentially what a brim is here where the model touches the build plate, here, around the whole circumference of this cylinder right here, it will create a few thin layers of plastic attached to the model. What this brim does is it makes sure there's a solid, flat base that really has a large footprint on the model. And so the larger this sort of footprint is, the more it sticks to that build plate and prevents sort of warping up on the sides. So you always want to have a brim check marked. In cases where you don't want to have brim check mark, if you're doing very, very tiny things, right, tiny things, especially like little screens or little strips or something, you don't want to have a brim on that because that'll be very difficult to take off later. Right, but for something like this, like kind of big models, big massing models, right, you definitely want a brim on there, or else this thing is not going to work. Right, so this should be your kind of default settings. For this print, I'm going to put it on draft as well. I'm going to click transfer as well. Anytime you change a setting, you have to kind of transfer all of them. So yeah, these should be kind of your default as you're going in to do a 3D print here in Prusaslicer. Now to actually convert it from your digital model here into physical layers of plastic, we go down here to the bottom right and hit Slice Now. Give it a minute, you can see the process bar down here. Sometimes it takes a while for this model since there's some curves and it's a bit larger. It'll take a little bit. I should have meshed this beforehand before exporting it in STL and Rhino. Do as I say, not as I do. But we can see it kind of ghosts out here when it's slicing. As long as it ghosts, that means it's slicing. So the second it turns solid here, we can see sort of its sliced view then. You can see this sort of operates in the same XYZ as Rhino. You have X, which is left and right. You have Y, which is back and forth. And you have Z, which is up and down. Right. Wow. That is a lot of supports. You can see All of the supports here are in bright green. This is that sort of gridded support material that it creates on all overhang conditions over 45 degrees. You can see this is over 45 degrees here, so it creates support for the inside of this dome. You can see also the model looks kind of stripy and weird right now. That's because it's displaying it all in individual little layers of plastic, as you can see here. The orange are sort of exterior perimeters. The yellow is an interior perimeter. Red is simply the top plate. Blue is an overhang perimeter. And this sort of turquoise down here is the brim. You can see this little brim that just sticks to the model to make sure it sticks to the build plate. And there's this little other turquoise element that goes around your entire model. That's a skirt. To know that your model is entirely flat as well, to make sure there's no parts sticking up, to make sure you orient 3-pointed it correctly in Rhino, you can check to make sure it's flat by seeing if your skirt goes around your entire model. Right? If it doesn't, it would go through this cylinder here halfway, and then you know your cylinder would be skewed. But mine is perfectly flat, so it goes all the way around here on the edge, right? So we know it's flat. Another way we could check if something is flat, and we can check our sort of infill density, is we could scroll through each individual layer of plastic it's going to print. And you could do that simply by holding left click on this little arrow up here and then dragging down. And you could see it drags down through each and every layer, and we can see that infill grid pattern there in red as we go down. So if we go down to the first layer, you could see this first layer is entirely flat here. There's no sort of skewing, there's no sort of angle that this first layer is on. It is completely flat. That is exactly what we want. This purple being the solid infill here on the bottom as well. And we can go all the way up with that red infill being there. I can show, so we can change our infill. We could bring it up to 10 instead. Every time you change a setting, you see it just went kind of yellow here and all the information up here went away. Every time you change a setting, you have to reslice it. So you click slice again down here at the bottom right. And then we wait for it to slice again. It might take a little bit. Again, be patient. And you can see the density of our infill here, the density of this grid has increased, right? And that'll affect your time drastically. Okay. Right here, you can see, is our total time for the 3D print, 17 hours and 11 minutes. Now, beforehand, when our infill was at 5%, when it was less dense in the middle here, it was at 15 hours. So us just bumping it up to 10 costs us 2 hours of time. So you have to be very particular with your kind of settings that you do here. So I'm going to put it back down at 5%. And I'm going to keep it at 10%. And I'm going to bring our layer height down to 0.15 speed. And click transfer. Now we're going to slice the whole thing again. And I'm going to show you just how drastic the time is going to change just by changing our layer height. It'll probably go from 17 hours to well over 24 now. Right, we're halving that layer height, so there's double the amount of layers that it has to print. It probably went from 1,000 layers to 2,000 layers of printing time. 20 hours. We just added 3 hours of time to our total printing time here. So now you can see the effect that these settings have on our print. We can scroll all the way up through our layers to complete them. So right now, you can see the time breakdown of sort of each component of your 3D print. You can see the perimeters, you can see the orange perimeters, you can see the tops, but you can see that our support material is taking up 8 hours of time. 8 hours of time. Now, there are a few different types of patterns of support material to sort of reduce your time. The way to reduce time, the way to change sort of support material configuration is to first of all go up here. I'm sure yours says simple up here. These are just different types of settings. You have simple settings, you have advanced settings, you have expert settings. What I want you to do is click on expert settings. I am already on them, so when you click them, some things should change and it should look more like this right here. So after that, we're going to go into print settings, and then we're going to go down to support material. From support material, we're going to see where it says grid right here next to style. Where it says grid, we're going to switch to organic. Now what organic supports do is they create sort of strange tree-like branches from the bottom of the build plate all the way up to our overhang condition here. I highly recommend organic supports for overhangs that are significantly above the build plate. Things that are pretty low overhang on the build plate, a typical sort of different style of support pattern is fine, but for something that is this high above the build plate, it's much more efficient, much more time efficient to do a tree support, or an organic support rather. You can see here the weird sort of tree branches it makes as it goes up. This conserves a lot of material, and it obviously conserves a lot of time as well. There's another type of support pattern for if your overhang is lower on the build plate. So right here, instead of organic, we can go to snug. These will generate in the more typical kind of blocky, gridded type of support material, but they are very much more easily removed than the grid type of support material, and they take a lot less time as well. They're not nearly as dense. I suggest never using the grid style of support material, never using this setting. Always use snug or organic, depending on your situation, obviously. We wait for this to slice again. You can see this takes 18 hours now. With this support material, it doesn't look quite different from the grid, but I promise you it is quite different. Much easier to remove, much easier to remove. Okay, to return to our sort of configuration view, we can click on this little cube at the bottom left. This cycles through from sliced view to your sort of regular configuration view. You can go back and forth and back and forth. And down here as well, when you're out of your sliced view, you can see the total time as well. But right now we're going to click on our model, and we're going to see a number of tools over here. All right. And now that we're in expert mode, we can see all of our full tools. This first tool is simply just a moving tool. So you can move left and right, you can move back and forth and up and down as well. This is our scale tool, right? If things come in at a weird scale, if you want to maybe make things a little bit bigger, but don't want to go through the process of going through Rhino, if it's not something that needs to be very precise, right? You can just scale it in here in Prusaslicer. Or if something's just a little too big when you brought it in, you could bring it down a little bit just to make it print. So we can bring it all the way down here, or we can bring it all the way big, or we can scale in one direction, or we can scale in another direction, right? You don't want to ever scale in these directions unless you're doing something funky. You always want to scale diagonally with these orange cubes over here, so you're scaling uniformly. Right. I don't really suggest scaling things here directly in Prusaslicer. I would much rather them, especially for something like a final model, something that needs to be very precise, doing it in Rhino instead, and then just sort of tweaking it from there as you go along. So the next tool down here is our rotate tool. It's kind of like a gumball tool in Rhino. So you can click and hold. So you can left click and hold this green box up here, and you can rotate along that axis as well. And if you want to snap to a certain degree, you hover over the white line, just like I'm doing here, and it snaps to every 5 degree here. So if you want to snap to 90, you hold over the 90. If you want to snap to 180, you hold over the 180, so on and so forth. And you can do that with each and every sort of angle here as we go. Below that is the place on face tool. This could be very helpful if you didn't quite orient something correctly in Rhino. It'll give you sort of varying faces of your model here interpreted from the STL file. And what you'll do is you sort of click on this white surface here, and it orients it on that surface. So if we click to this surface here, it orients it on that one. If we click to this one here, it orients it on that one. If we want it flat again, we can click on the bottom and it orients it on that one. Very simple, right? And very easy in a pinch if you're doing things very quickly, and if you want to orient something differently. Like if you're doing the roofs to your sort of little building, like I did in Rhino, where you're cutting them off and sort of rotating them over. If you didn't bring it in right, you brought it rotated the wrong way or something, you could use this tool to sort of put it on its other face, just like that. Or put it on this face, just like that. Right. Another very valuable tool is this cut tool as well. You can cut things here in Prusaslicer. Now, I don't really recommend doing this unless you're doing sort of fun models, things that don't really need precise calculations and need to fit into each other very nicely. Just for kind of quick last minute things, I recommend doing all the cutting and things and like Rhino like that, so it's very precise and you know what you're doing. But if you do need to use this tool, you can hold left click on this little ball and it'll go up and down. If you need to rotate the cutting plane, it works just like the rotate tool. You hold left click on one of these little arrows and snap to one of these white lines here and it snaps to them. You can do that in either direction. And then once you're at the angle you want to cut, you just go down here and you click Perform Cut. There's a few options here, I won't get into them, but you just hit Perform Cut. It'll take a minute because it needs to interpret the mesh, the new cut mesh. And there, it has cut it into two pieces now. So we'll click off of them, and now we can click on them and sort of hold left click and drag them around here however we please. So they're two separate pieces, they're two separate files now. Okay? I'm going to undo that actually because I don't want that, but that's just showing you how the tool works in case you want to do something like that. Okay, so below that is the Paint on Supports command. This is essential if you don't want to use the sort of auto-generated supports that exist within Prusaslicer here. They're very important if you need to do very precision supports only on a few surfaces. So what you could do, you could see there's sort of a little brush I have, this little dark sphere that I have. That's our brush we have selected. So right now it's a brush, and you can see down here it's a sphere, our brush shape, our tool type. We have a brush and we have a sphere. We can change it to a simple circle, or we can change it to a triangle, right? Our whole sort of STL file is tessellated, it's meshed, so it's all just made up of a bunch of triangles. So we can select one of those triangles if we want. What I like to do is not use a brush and go down here to this Smart Fill command. What this does, instead of just doing sort of a little section of something, it does the whole face. So it interprets from your mesh the different faces, and you could do it like that instead. Now if you want to remove your selection, you hit Remove All Selection, and it deletes all of them just like that. Right now, what I'm going to do, since it's generating supports right here, and maybe for some reason I don't want them to generate, what I can do, instead of left clicking to sort of force supports there, I can right click to exclude supports there. So it goes red if you don't want supports there. So now, in order to sort of put this enforcer into effect, I have to switch supports from everywhere to support enforcers only. What we're doing is we're creating support enforcers, right? Just different types of support enforcers. So if we slice it again, and if we wait, and now, as you could see, there are no supports on our overhang. Now obviously you don't want to do this in a realistic situation because it wouldn't print, but I'm just showing you how the tool works. So if we go back into our configuration view now, and we change this from red to blue, we can have it so our supports generate again. Just like that, they're back. We can go back to our configuration tool, and instead of using the Smart Fill on the Paint on supports, we could use the brush. So what the brush does, if we have our sphere brush size selected, is we could just paint on supports instead. And it does the exact same thing. It generates supports where it's blue, and where it's red, instead of holding left click, we hold right click for red. It doesn't make supports, right? It does the exact same thing. And you want to make sure you're doing this on overhangs. If you do it just on the wall here, it won't do anything. Okay? So I'll now remove all of my selections and make sure if you're not doing supports anymore, you change it back to supports everywhere. Okay. And below that is seam painting. We're not going to get into that today. And you can also use a measure tool here in Prusaslicer. Just to measure certain distances from here to here or from up to down. You shouldn't really need to do this. You should know other things because you'll have your Rhino model open as well. But just in case, here it is. Before we go and actually print this in the laser lab, what I'm going to do is save this file. So all I'm simply going to do is go up here to the top left and hit Save Project As. Okay? You can see I already saved a previous version of it, but I'll save another version of it, so we'll just call this 3D Print Video Demo 2222. And this will save it as a .3mf file. Now, we'll press Save, and it should save. Now it's important to know that this is not the file you will put on the 3D printer. When we go into the laser lab, what we should do is open up this .3mf file. And then from this .3mf file, we will hit slice, and then we will wait for it to slice. Okay, this is the file that you would like to save onto the SD card once we're in the laser lab. But we'll get into that once we're over there. Okay, so here we are at the Seed Center. The Seed Center is located behind Deck and Reichland House here at the end of this road. This is where our print lab and laser lab facilities are located. To get into the Seed Center, of course, you need your campus ID, which I have here in my wallet, and you just scan the door and it opens. You have to do this a second time, and the door opens again. So once you're in Seed, you'll go straight back this hallway, and then right here, before the vending machine, we'll take a left. Here are the doors leading to the laser lab. You'll also need your campus key to get into this room. Mine is inside my wallet again, and you have to scan right here. The door opens, you turn, and you push to open. So here we are in the laser lab. Our laser cutters and our laser cutter storage system is over here. And here is the stacks for our 3D printers. Now, some of the first things you'll notice when you come into the print farm is that there are a few models over here showcasing what 3D printing is capable of. Here are a few examples of infill patterns like I showed in Prusaslicer. You can see we have 2%, 5%, and 10% here in real life. You can see that grid pattern on the inside of the model. You can see a few other examples of things that we can do. We could print very delicate screens, curvilinear formwork here, and then huge multi-part skyscrapers here. This is, I believe, in 3 parts. There's a bunch of different things you can do. These gray prints here are with our powder printer, which is right over here, and there will be a separate tutorial on how to set up files for that. Okay, so going away from that and over to our actual print stacks right here. This is where the majority of our 3D printers are. I believe we have 14 of them right now. These are our workhorse printers. These are our Prusa Mark III S's, like we set up in the video. This is a specialty printer up here. There will be a separate tutorial for file setup on this one. One can print very quickly, and it can print with multiple colors of filament. That's what this thing up here does. Okay, some other things to note are, of course, these signs here, right? If you need any help with anything, mine and Drake's email is right here. You can shoot us an email if there's any problems with anything you encounter in the print lab. But if you do encounter some problems with the printers themselves, please, please, please submit a maintenance report by scanning this QR code here. It's right here. These signs will be replaced. Right now they're not in the best condition. Those will be fixed pretty soon. Okay, and here are our 3D printers. Here they are. You can see right there, it says Prusa i3 Mark III S. Okay, so this is what you want to be looking for. And it's not running right now. There's nothing going on it. This is the machine we will want to use. You are free to use all of these machines as long as they are not running. As long as they're stopped like they are right here, it's perfectly fine to use. Even if it has an SD card in it, like this one right here, as long as it's not running and there's nothing on it, you're free to take the SD card out and use it. Additionally, if you see a 3D printer that is either off, so the screen is off, or has one of these tags on it, that means that the printer is not serviceable. Please do not touch it. Please do not try and use it under any circumstances. It is broken and requires substantial amounts of work to fix. Okay, so here I've set up my laptop, and you're free to set up your laptop at any one of these seats here over next to the print farm and plug your laptop in case you need to do some file editing while you're setting up your 3D print. So here I have a file we saved just a short bit ago, 3D print video demo 222. This is the .3mf file, so what you're going to do is double click on this to open it, and it should open Prusaslicer shortly. Okay, so here it's opened. You'll be prompted with a box. When it opens up the file, you just want to press OK.
and then it should load in for you with all of your settings that you previously saved. Okay, so here's our model, just with all the correct settings that we put it in yesterday. I'm going to turn our infill from 10 to 5%. I think that's best for this 3D print. We don't need to go excessive with the infill. It's not something that needs to be that strong, right? Okay, so now, once we're in this screen, we'll go down to the bottom right, and we'll hit Slice Now. And we'll wait for the model to slice. Okay, so our model has successfully sliced. You can see right up here is our total time. It is under 24 hours, so it is okay to print. And now, from this menu, what you want to do is turn around and grab an SD card. These are the main file formats that you use to transfer your file from your computer onto the readable file that the 3D printer can use. So I thankfully have an SD card reader right here on the side of my laptop. Everybody may or may not have this. If you do not have an SD card reader, that is perfectly okay. We have SD card adapters right here hanging on the wall. You just want to take one of these. It's got an adapter on the end of it, so it does USB-C or it does regular USB. I'll plug that in the side just for the sake of showing you. And I'll take the SD card right here and I'll put it in the side here with the gold pins facing up. So just like that, and there we go. And you'll hear it plug in here. And if this pops up, you want to click on it, click Scan and Fix, and another pop-up will go down here. You want to click Repair Drive, and then hit Close, and it'll open up the SD card. Now, good sort of etiquette for the print lab here is whenever you plug an SD card into your computer, you take what's ever on it and delete it all. This just makes sure the SD cards are always open and they don't get full of files over time. Okay, we can exit out of that. And now to export our sliced file, or G-code, this is the type of file that the printer reads. It's completely different from the .3mf file that we saved earlier in the video. This is a completely different file that only the 3D printer can read. Only these files should be uploaded to the 3D printer and put on the SD card. So to put it on the SD card, what we do is we click this little orange button down here. If we hover over it, it says Export to SD card. So we click on it, and it takes us right to the SD card, right? So what we want to do when we name our file is we want to delete everything that isn't the time, the total time it takes. So right now, we just have 11 hours, 1 minute, so the total time this will take. What you want to do is you want to type in your name, so I'll type in my name, Owen Felty, and then after that, we'll put an underscore, and then we'll put in our phone number as well. So I'll put just a fake number in, just like that. This is just in case your print fails and you have already left the lab. We can contact you so you can come back here and we can look over your file just in case anything happens. So we'll hit save. And then right down here, you can see it says exporting finished. And once the export has finished, you click this little triangle right here that says eject drive, and it ejects the SD card. So we can take this out now, and you can take the adapter out now and go put it back on the shelf over there. So now you have your SD card and you're ready to put it on the 3D printer. If there's already an SD card in here and there's nothing sort of on here, or the printer's not moving, you can just take the SD card right out and put it back in the little yellow holders up here. Okay? To put your file on, what you want to do is you want to take the SD card with the gold pins facing towards you and put it in this side slot here. You can see it right there, and just put it right in, just like that. And you can see my file is right there. It pops up automatically. To scroll, what we use this little knob here, and we scroll down. So that arrow goes right over our file, and once it's over your file, it should scroll through the whole thing. So we should see our name, our phone number, and then the total time it will take. To select our file, what we do is we press the knob once. This has nothing to do with you. This is just my fault here, so ignore this, and press the knob again, and your print will start. So what it's doing now is it's heating that bed, like we talked about in the video. So it's heating it up. You can see here it's at 17 degrees. It'll heat it up to 60 degrees. And you see it's heating up the nozzle from 45 degrees to 215 degrees. You can see right here is your total time remaining, 11 hours, 10 minutes. This will count down all the way to 0 when your print is done. Okay, and we'll just wait for it to start then. Okay, so our print has started. The 3D printer is first going to level itself. It does this for the start of every 3D print. It levels itself on 9 points across the build plate. If it sees that all of these points are level, then it will start your print. If it doesn't, then please submit a maintenance report. Something is wrong. And you can see here, it's putting just an initial layer of plastic down. It does this to just calibrate itself.
Hey, it's Owen here, after the fact, editing the video. I forgot to mention in the video that you should stay for the entirety of the first layer printing. If there's anything that's going to go wrong in your 3D print, it's going to be in that first layer. So you should stick around, I'd say, for 15-20 minutes. If everything appears fine in that first layer, then you're good to go. 99% of the time, if your first layer prints, your 3D print will be fine. Just wanted to mention that. Okay, now back to the video.
And there starts our 3D print. If you start your print and it looks like this, where it's stringing sort of on the edge here, especially when it goes around corners like that, that means there's something wrong with the printer. What you should do immediately is press the knob here and scroll down to where it says stop print and press the knob. And then click to yes. You need to stop your print. There is something wrong with the printer. Please submit a maintenance report by scanning that QR code here. There's a number for each one of these printers. You'll put in the number at the maintenance report and we'll come and fix it for you. Alternatively, if you start your 3D print and it looks something like this, where the plastic is smushed into the build plate and it looks like the nozzle is struggling to put out the plastic, or it's building up on the physical print nozzle itself, please click on the knob, scroll down to stop print, and hit yes. And then please submit a maintenance report for this specific printer. Once your 3D print has finished, you can go ahead and take the build plate off the 3D printer. This is very simple. You just take it up by one of these corners that are overhanging right here. You just take it right off. And normally, to get a larger 3D printer off, you can bend it. This is kind of hard with one hand, but you can kind of bend it and it would pop off. But for smaller 3D prints like this, it's much better to just set the plate down, grab a scraper from the shelf, and then scrape the print off yourself. There we go. And make sure to get all the plastic off of the build plate, including the little probe at the start. And here you have your 3D print. Now you can take the brim off. This is the brim we added so that it would stick to the build plate better, just with a little X-Acto knife, or sometimes it comes off with just your hands, like this one here. Just like that. Make sure to throw away all your loose bits of plastic. Put back the scraper, and put back the build plate. Now you can see the back of the build plate is notched here. These notches align with screws at the back of the 3D printer. You can see they just slot in like that there. So put it in with the back facing to those screws and then drop it down and it's perfectly fine, just like that. You have successfully 3D printed. Over on this side of the 3D printer shelves, we have a few tools here. These are some pliers. These are handy for getting bits of stray plastic off the nozzle here of the 3D printer, like there. If it tends to gunk up some plastic on the nozzle, you can just use these to take them off. These are Allen wrenches. These are for shop use only, for when 3D printers get broken. These back here are alcohol wipes. This back here is called 3D lac. This is a glue stick. And here are our stacks of filament here. Behind here are our colored filaments. We only have a few right now. We will be getting more soon. And here is our regular filament, our Polyterra sort of off-white filament that we have at the front. I'll show you how to change filament right now. So you want to change filament. It's a very simple process. All you have to do is go to our little screen here and go to our little knob that you have here and press the knob. Scroll down to where it says unload filament if filament is already loaded in. If you're on a printer that's, say, one of these that does not have filament in it, you have to click on the knob, scroll down to where it says auto filament instead, auto load filament instead of unload filament. For this one that we're using on our example, we will do unload filament because this is the most common scenario. We will scroll down to PLA, just like we selected in Prusaslicer. It's all PLA filament. So we should select that by pressing the knob, and then it will preheat the nozzle of the printer, so that guy down there. And once it is done, it'll let you know further instructions. Once the nozzle has heated itself up, you can see here the screen has changed. You can see it's of sufficient temperature, 215 out of 215, and all we have to do now is press the knob to unload filament. So we'll go to our knob here and we will press it. And you can see here it comes out the top of the print head. All we have to do is grab it right here and take it out. You can see it gets a little stringy here. You want to take those off. And then you want to take your filament here, and if it's a colored spool, it goes back here. And if it's an off-white one here, it goes on the front. So this one will go back here. So then we will take our off-white spool here and make sure you find the end of this filament spool here, and we want it going over here. We want it coming down. So we put the filament on the little holder here. We take the end of it right here and we put it in this top hole. That's right. I know it's a little hard to see, but it's right in front of this screw here. And you want to take it and you want to put it in, and you'll hear the filament go in, and if you put your fingers right here, you will feel it go in as well. And then down here it says loading filament. And then if we look at the nozzle of the print, you can see it's turning from that neon green color we had, slowly turning to white. Now it will stop after a short time and it will ask you if it's extruding the correct color. Verify that it is or isn't. Ours is not, so we will scroll the knob down to where it says no and then click it. And it will continue to extrude until it gets us to that white color. It will ask us again. We will click yes, and then we will take off the bit that it has extruded out. And now you have successfully changed filament.
Okay, so you've made it to the troubleshooting section of the video. This video basically outlines any adjustments you can do or make in the Prusaslicer program to fix anything that's going wrong in your 3D prints. The first thing we will notice is with these few cubes here, just like I set them up in the Rhino file, that they are outlined here in this sort of bright blue. This denotes sort of an open poly surface or an open area, just like the show edges command did in Rhino. You can see Prusaslicer also shows open things. So if you miss something with the show edges command in Rhino, it will also show it in Prusaslicer. Now, if we try and slice something like this by simply hitting the Slice Now button, you can see we get an error message at the bottom right saying no layers were detected. You might want to repair your STL files. So if you put in open files into Prusaslicer, it will outright not slice them. So you need to go in, back to Rhino, and then reslice them. So we can go back to our configuration view here. And unfortunately, what we'll need to do is either delete these or go over here. If you're in the expert settings mode, which you should be in, you should be able to see all of your objects here, and you should be able to see your errors that you're getting here. Now, normally, I would much rather you just delete these objects by clicking on them and deleting them. But in rare cases, if you've gone back into Rhino and you've repaired your entire model and it's still coming in as open in Prusaslicer, what you can do is you can hover over this triangle and right-click, and it will repair your model automatically. Right? But this takes some leeway, right? It doesn't always do what you want it to do. These obviously are just little simple cubes. It's very easily fixable for the program, right? But maybe it does something a bit wrong and it messes up your print, right? That's something you don't want. So you want to have precise control over which edges are closed and where they're closed at. And you could do that in Rhino. right? This is sort of last case. If you're really, really desperate, you should do this. Right now, I'm just going to take these and delete them simply by clicking on them and pressing the delete key. And you could bring models back in again with the cube and the plus sign. And these are multiple models as well, so you can bring in multiple models as well into your Prusaslicer build plate here. Now if we slice it, we can see a few things. First of all, we can see the support material that has been generated because I have supports everywhere. We can see the brims that exist around the bottom of each object here because I have those selected. And if we scroll down, we could see the small amount of infill because I have a 1 infill here. Very, very low infill. Okay, but this first cube right here is perfect. You can see the brim wraps around entirely around the object here, and the skirt on the edge goes around it here as well. So it's not off the surface. If we scroll all the way to the first layer here, we can see that it's perfectly flat, right? No problem. Same thing with the stairs here. Perfectly flat, brim wraps all around, no problem. But with this cube over here, this is the skewed cube. This is the one we performed the Orient 3-point tool on. But this one I just brought into Rhino, skewed, so I could demonstrate it for you. You can see the brim doesn't wrap around the entire bottom of the edge here. It actually stops right here. Right? And we can see also that the top is slightly angled. These are clues to show you that your model is not flat. And if we scroll all the way down to the bottom, we can see that it should be exactly like this here, but it's not. It's slightly skewed, and it's actually angled on the bottom, and it will build up angled. Luckily, this model has interpreted it, Prusaslicer has interpreted it, so it puts support material under there. Not all models will do this, and it will be catastrophic for your 3D print. It will not work. So save yourself the headache and just make it flat in Rhino and bring it in. Okay, and we can see over here, with our last example here, that our overhang is being made. Right? What we can do to sort of negate this overhang is simply just clicking on it, using our place on face tool and clicking the bottom face, and it rotates it completely 180. And when we slice it again, no supports needed there. It just saved us probably 10 or 20 minutes of print time there. And you can see it's flat on the build plate again. Very, very important. These are a lot of problems I see in the print lab. People bringing in files that are not flat. Make sure they're flat. For things like stairs like this, I kind of told you this in Rhino already, but here you can see it actually illustrated. You can see this is the sort of continuous surface one where I move the block underneath each stair to make it a continuous solid. And here you can see each individual stair is printing. It's not a staircase, it's just one stair after the other. Right? So you need to make sure it's a continuous sort of solid and not just individual little units that are just kind of next to each other. Also with these stairs, I would highly suggest rotating them on their side. You can do this either with the rotate tool and then holding left click and snapping it 90 degrees on its side, and it snaps to the bottom of the build plate. Here you can slice it. You can see it's flat. The brim wraps all the way around. Or what you can do is click on it and then go on your place and face tool and then click the face that you want on the build plate, and it does the exact same thing. And there you go. So, what if you're having other issues? What if you still put your model flat on the build plate and it's still not working? What if it's a little cold outside and it's cold in the laser lab and things aren't sticking to the build plate? That's perfectly okay. What we can do is we can adjust a few settings to try and make it so your 3D print, that first layer, sticks. Because when it comes to 3D printing, right, that first layer is the all-important layer. That's the layer that everything will be built upon. So if that first layer isn't absolutely perfect, then everything's going to fail. So what we can try and do to sort of negate this from happening is go up here to Print Settings, and then we will go down here to Speed. And instead, we go down here to where it says first layer speed. And instead of it being 20, we can make it 15 instead. And we can go back to Plater and then slice again because we changed the setting and we need to slice it again. Now this will add a bit more time to your print, probably about, well, it varies a lot on the size of your print, but probably about 20 to 30 minutes. But it will slow down the 3D printer robotic print head on that first layer, so it can really precisely and really sort of steadily make that first layer very well. because the faster it goes, the more aggressive it is, right? And the easier it can rip that first layer off. If it's going nice and slow, back and forth, it can take its time and really make sure all that plastic is sticking to that build plate. Okay, what also we can do is we can go to Filament Settings, and we can go to right here under the temperature section, and we can go to Bed. And right where it says first layer, we can bump it from 60 to 70 degrees. Right? What this does is each build plate of a 3D printer is heated. So when the plastic is deposited onto it, it is nice and warm and it sticks for a little bit, right? If you put a hot piece of plastic on a cold build plate, it will not stick. It'll just come right off. If you put a hot piece of plastic on a hot build plate, it will stick there very, very well. So if we up the build plate temperature even more, it will stick even better. So the maximum I would go with this is 80 degrees, okay? If you're having minimum trouble with build plate adhesion, I would just bump it up to 70, as well as bringing down the first layer speed. I'd say the minimum you'd go with this is 10, and the maximum you'd go with the build plate temperature is 80. Now don't change this one over here. This is for all of your other layers. It only matters your speed or your build plate temperature on that first layer. After that, it's fine. Nothing else will be affected by it after that first layer. So you only want to change that first layer. Same with your speed here. Only mess with first layer speed. We won't get into anything else at this moment in time. Okay. This will affect a little bit your time, right? We're up at 5 hours and 26 minutes from 5 hours and 8 minutes, but it will make sure your print prints properly. Right? There's also another method to sort of make build plates, make prints stick to build plates. We have some glue sticks in the laser lab called 3D Lac, and we'll go there now to show you how to use it.
So now that we're in the laser lab, I can show you how to use this 3D Lac stick. But before we get to the 3D Lac, I will tell you about these. These are alcohol wipes. If you're having trouble with build plate adhesion, you can use one of these. You just take them off from the pile there. There's usually a good stack there. I keep them pretty stacked up. And then you rip it out of its little pouch, and it looks something like this. And then you take it and you wipe the build plate down with it, just like you're cleaning off a table or something. You want to make sure you get the entire surface nice and clean. And there, make sure there's no residue from other prints on there, and if you have to use more than one to get it fully clean, then please do that. If you have cleaned off your build plate and it is still not sticking and you have tried everything else, the absolute last resort is to use this 3D Lac stick that is sitting right over here. To utilize this stick, there are instructions on the back in case you forget, but to utilize the stick you have to shake fairly thoroughly, and you have to take this cap off. Now it is fairly similar to a bingo stamper in operation. You have to put it down and you have to hold it there while putting pressure in the middle of the build plate here. I'm putting constant pressure on it, and you can see putting constant pressure on it, constant pressure, and it should start putting the glue out. There we go. So there it is. You can see it just barely there on the camera. But apply this glue only to where your 3D printer will be on the build plate. So if it's a big square like this is here, then put it there, right? It shouldn't be all the way out here on this corner and this corner and this corner and this corner. Only where your 3D print will be. Don't use it excessively, okay? And make sure to just keep putting constant pressure on that build plate. Constant pressure so it keeps sort of bringing that glue out of the bingo stamper. Okay, and now that we have it here, we can put the cap back on and put it back over here. And then what you have to do is you just have to wait for it to dry, and then you can start your 3D print again. And if all else fails, if that does not fix your build plate adhesion issues, please send me an email or submit a maintenance report for this specific machine, right? And we'll get to it. So that does it for a basic 3D printing tutorial. There will be supplemental tutorials on how to use our powder printer, our bamboo printer over there, our clay printer, and maybe eventually our large form factor Modix printers. If you have any further questions on 3D printing or would like to learn more, or maybe come work here at the Laser Lab or at the Print Farm, my email is right over there. I'll put it on screen right now as well. And there will also be a separate tutorial for how to use the laser cutting machines over here and how to submit files for them. Okay, thank you very much, and I'll see you around.